This is SpaceX Starship. If Starship is the most powerful rocket ever built, why won't the trip to Mars feel anything like a grand adventure? Because despite its incredible potential, this is no luxury cruise. The journey will be long, dangerous, uncomfortable, and mentally exhausting. The real question is, can humans endure the harsh reality behind this historic mission? Now, if Starship isn't a luxury ship today, what was it supposed to be at the beginning? The original vision was bold, almost sci-fi. Imagine stepping into a spacecraft where the entire upper half is one continuous open space for crew and cargo, offering about 1,000 cubic meters of room to stretch, work, and live. Picture massive panoramic windows wrapping around the nose, giving travelers a breathtaking view of the stars. So here's the question: why did SpaceX abandon such an incredible design? The answer comes from reality hitting hard, literally. When SpaceX began flying early Starship prototypes, many of those landings ended in crashes and fireballs. Engineers quickly realized that the fuel needed for the landing burn had to be relocated. Instead of storing it near the bottom, where the ship swings like a pendulum during its flip maneuver, SpaceX moved the header tanks up into the nose cone to stabilize the landing phase. And what did that change cost us? Everything in terms of interior luxury. With fuel tanks now occupying the entire pointy section, the nose became completely off limits for the crew. Those stunning panoramic windows, gone. That massive open deck, no longer possible. So the big question becomes, to make Starship land safely, how much comfort are we willing to sacrifice? So after losing that grand open concept layout, you might wonder, could SpaceX make up for it with a bigger rocket? Surprisingly, they tried, and the results were not what anyone expected. To meet the new requirement of carrying enough propellant to return from orbit, Starship V11 was built physically taller. That sounds like a win, right? A bigger rocket should mean more room inside. But here's the twist. Even though V2 grew on the outside, it actually shrank on the inside. Why? Because the only way to fit more fuel was to extend the tanks upward into the habitable section. The very space that was meant for people became the space needed for propellant, and the consequence is hard to ignore. Usable interior volume dropped to about 500 cubic meters, cutting the living area in half. So the real question becomes, how do you design a home for Mars travelers when every extra meter is claimed by the rocket itself? As Starship keeps shrinking on the inside, the next big question naturally comes up. How many people can we realistically send to Mars without everyone losing their minds? To answer that, let's start by comparing Starship to something we already know well, the International Space Station. The ISS has about 900 cubic meters of internal volume and comfortably supports a crew of 7. In emergencies, it has even held up to 13 people. That gives us a baseline for what humans can tolerate long-term in space. But here's where NASA gives us a hard dose of reality. Back in the year 2013, they commissioned a study to determine the minimum habitable volume needed for a 2.5-year round-trip mission to Mars. Their conclusion? Each astronaut needs at least 25 cubic meters of general living space, not luxury space, just enough room to avoid psychological strain. Using that metric, Starship V2, with about 500 cubic meters total, could theoretically support around 20 people. But theoretically is doing a lot of heavy lifting here. That calculation doesn't account for the floors, walls, and ladders needed to divide the rocket into usable decks. It also doesn't consider the fact that the entire lower level must be reserved for an airlock and cargo bay, meaning a big chunk of that volume is untouchable for crew living quarters. So what does that leave us with? Realistically, maybe 6 people could travel comfortably on a long-duration mission, but here's the problem: 6 humans won't colonize Mars. So the real question becomes, how do we balance the physical limits of a spacecraft with the ambitious dream of building a new world? So how do we escape the cramped reality of Starship V2? Enter Starship V3, and here's the exciting question: what happens when SpaceX stretches the rocket to a towering 69 meters? The upgrade adds about 17 meters of length, allowing for larger fuel tanks and improved performance. Not all that extra space becomes living area, of course, but the result is still remarkable. V3 brings the interior volume back to nearly 1,000 cubic meters, reviving the original vision of a spacious, livable Starship. Now that Starship V11 finally gives us the space we need, the next big question is, how do we actually build a livable interior inside this massive metal tube? The answer starts at level 1, the foundation of everything. Down here sits a circular airlock, the gateway between the safety of the ship and the harsh environment outside. This is also where astronauts suit up because the EVA suits are stored right inside that ring-shaped chamber. Step beyond that and you enter the unpressurized cargo bay, packed with tools, scientific equipment, mobility devices, and everything needed for exploration. But the most striking feature on this level is the elevator, a long, exposed lift that carries astronauts all the way down to the surface of Mars or the Moon. It's simple, rugged, and absolutely essential. So where do we go from here? As we climb toward the next level, the design shifts from survival to support. The ship transitions from raw functionality into the systems that will keep a crew alive for years. And that leads us to the next question. How do you store everything humans need, water, oxygen, food, waste, inside a rocket without overwhelming the limited space? As we climb into levels 2 and 3, the question becomes unavoidable. How do you pack an entire life support ecosystem for a years-long Mars mission into just 2 decks of a rocket? Level 2 is where the essentials take root. This floor holds the pressurized storage that keeps the mission alive, the water reserves, the oxygen tanks, the HVAC systems, and all the food and waste storage. Everything heavy is positioned low to maintain the ship's center of gravity stability, especially during landing. It's the engine room of human survival, even though it doesn't look glamorous. But level 3 is where daily life gets real. This is the hygiene deck, and here's the first surprise: you won't be taking showers. At best, you'll sponge bathe with a rag and wash your hair with dry shampoo. The bigger challenge, though, is water. Without recycling, a crew of 10 would need 27 tons of water for a 900-day mission, an impossible amount of mass for a spacecraft to spare. With recycling, that number drops to just 3 tons, a requirement made possible because the ISS already reclaims 93% of its water by filtering urine and dehydrating solid waste. Moisture is extracted, purified, and fed right back into the supply. To manage all of this, SpaceX plans to install rectangular hygiene pods around the circular walls of the deck, maximizing the use of space while containing odors. And because astronauts must exercise every day to prevent muscle and bone loss, the gym is placed on this same floor, keeping all the sweat, smells, and sanitation needs together. So the real question becomes, what does it take for humans to stay clean, healthy, and functional when every drop of water and every breath of air is recycled in a tiny world drifting through space? As we leave the hygiene and life support decks behind, we enter one of the most important parts of the entire Starship habitat, the crew decks. And that raises a crucial question. What does day-to-day living actually look like during a multi-year journey to Mars? Level 4 is where the astronauts will sleep, relax, and try to maintain some sense of normality. Based on what we know, this level would offer around 600 cubic meters of usable space. To help visualize that, imagine a fairly large home with 3 or 4 bedrooms and plenty of walking room. For space travel, that's actually pretty generous. But then comes the next question. How many people could realistically live here without going stir-crazy? NASA actually ran the math. According to their habitability study, this volume could accommodate up to 24 people without causing a psychological breakdown. That might sound surprising, but space agencies have decades of experience studying how humans behave in isolation. However, the Starship moon lander gives us an even better clue. The mock-ups and leaks suggest rectangular bunk modules that slot neatly into the ship's circular frame. Each deck could hold around 20 beds, which strongly implies that a practical Mars crew would be around 20 people. But here's where things get interesting. Elon Musk has famously claimed that Starship could carry 100 people to Mars in a single trip. Technically, yes, the ship has the mass capability. Comfortably? Absolutely not. Packing 100 humans into this space for months at a time would cross the line from ambitious engineering into what one might politely call cruel and unusual punishment. It would be like stuffing an entire apartment building's worth of residents into the floor plan of a single house, except the house is in space and you can't go outside for fresh air. Now, assuming we go with a far more reasonable crew of 20, that brings us to level 5, the mess hall and greenhouse. And here another question pops up. What will astronauts actually eat on a 2-year mission? The simple truth is that most food will be dehydrated and stored on board, then reheated by pumping hot water into sealed packets. It's functional, it's reliable, and surprisingly, astronauts on the ISS have managed to make even pizza work in microgravity. But what about fresh food? That's where the small hydroponic greenhouse comes in. NASA has already begun experimenting with growing plants in zero gravity, and Starship will likely use these early breakthroughs. Don't expect vine-ripe tomatoes or gourmet salads, but crew members could enjoy occasional fresh lettuce or herbs, small comforts that can make a huge difference on such a long journey. So, Level 4 gives us rest and privacy, and Level 5 gives us nutrition and a small taste of Earth. Together, they form the core of how astronauts will maintain both their physical health and their mental resilience throughout the mission. So the real question becomes, how do these upper decks transform Starship from a metal can into a functioning, sustainable home for interplanetary pioneers? Levels 6, 7, and 8 provide the answer: recreation, purpose, and command.